Hello, another video. This is for number 20, valid parentheses. For this problem, we are going to check if a string is valid, so true or false, depending on the pairs, depending on how these parentheses are paired up. So we want to have bracket to bracket, squirrely to squirrely, and just regular to regular, right? So this would be false. So one way to go about this is to basically check, okay, let's say we add this character to our stack, right? Let's imagine, I wish I could draw on the monitor. That'd be a cool feature. Let's say, yeah, I add the open bracket to the stack. Then the next thing that has to enter into my stack, the next character, right? If it's we're only dealing with parentheses here, so it's fine. But the next parentheses has to, if it's open, then we keep adding to the stack, right? So if we had a stack, we can keep adding open brackets. But the first moment we come across any kind of closed bracket, then we need to check what's on top of our stack, and if they match, right, then we're gonna pop that off. So since we are checking with the closed bracket, then we want a mapping of this is what we're looking for. So we can make use of a dictionary, because every time we see a closed bracket, then we can tell, the iterable, or within the iteration, we can say this is what we need to see on the stack to say that so far so good. Otherwise, then it's not valid. So again, if we come across this character, then on top of the stack has to be this character. Otherwise, it would not be valid. So same thing with the squiggly bracket. So we have our dictionary. So our keys are going to tell us what values they need to see on the top of the stack. And then from here, we have a good mapping. And I said that making use of a stack would be nice, because we're sort of saving up all of the open brackets that we've seen so far. So we'll have a stack. We are then going to iterate through the string. So we'll say character. And let's do P, or character, doesn't matter, for P standing for parentheses. In S, we're going to say, okay, well, P is fine. So we're going to the character. If the character, I keep saying character. Character is not in D, right? So if it's not a closing bracket, then we're going to add it to the stack. Stack at append par. So we keep adding the open brackets, right? So if it's not in the stack, we add it. Else, let's say, we came across something that's not in there. So it means, okay, we came across a closing bracket. We're gonna check, okay, from the top of the stack is here. Does this equal car? Sorry, no, yeah, car. So we're using the closing character as a key for this dictionary, and we're saying, okay, we came across a closed character. Does it match does the value of that match what's on top of the stack? If so, then we are going to pop off what is there on the stack. So if that is the case, we're going to pop it off. Oh, just pop, right? Miraculous. Stack.pop. And then when we do that, we lift an item from the top, and we don't have to add anything to the stack because, well, it's a closed bracket. So that's the case. But if it doesn't, let's say it doesn't match. So we got this curly bracket, but the top of the stack is, an open bracket. That's not going to match. So we can immediately return false here because we didn't see a match. So if we go to this entire iteration of all the characters in S without seeing false, then we can say, okay, everything is good. So the worst case scenario is, well, we have to go through all of the characters in S, and let's say, yeah, we have to go through all of them. We have to keep adding to the stack if it's an open bracket, right? If it's not a closed bracket. If it is a closed bracket, we're going to check the top of the stack with the value of that character in the dictionary. And if it matches, we're going to pop it. Otherwise, we can right away return false. I think one thing I wanted to check early on is actually the input. So I should have done this from the get-go, but if length of S equals 1, then we'll return false because you can't have a pair with just one character. Let's see how this runs. So far, so good. And that's wrong because our input is open. Sure, this is an edge case that I didn't take into consideration. So, that's interesting. So how are we going to tell if open is false? Well, if there's anything in the stack, that means there's not a pair that we didn't see. So if stack has anything, we'll return false. Let's try that. This is out of range. Oh man. So if the last value of stack equals the car, but if nothing's in the stack, then there's nothing to pop. Right, so else we need to check if there is something in the stack. Otherwise, we can't really do anything. Let's see. Output is true and I needed false. Wait, no, something's off. So we don't append it, right? Character's not in D, so we go here right away. Oh, and that's why we see the index error. Else, if stack is empty, then we have to return false. Don't we? Not necessarily, because it could be at the end. So if character is not in D, let's see, if character is not in D, which this first character is not, well, I mean, it is, right? If character if character not in D, then we add it, but it is in character. We something's off here. My logic's off here. Okay, so let's think about it. We have a mapping. If it's closed, we're going to check for the opening one. But what if off the bat we get a closed bracket first without the opening one? Well, the character is in dictionary, so we're going to skip the first if statement. We're not going to add the closing bracket. But if we can only pop if there's something there, right? So if there is something in the stack and the last element equals that character, then we can pop it. Otherwise, we'll just have to return false. Okay, that worked. So I didn't take into account that the stack had to be non-empty, right? Because if there was, a closed bracket right off the bat, then I mean we don't have a match for that, obviously, and there's nothing in the stack because we didn't add it. So I needed to check the stack, and well, the runtime isn't that fast, but we're still going through n characters in S, and then access is instant, so the runtime shouldn't really be this slow. So it jumped up to 85%. Doesn't make sense. Anyway, so yeah, just the intuition of the mapping and just adding all the open brackets to the stack is pretty neat. And just, yeah, again, you got to check if, I guess this is for an edge case, right? So got to check if the stack is has something.